What if the universe itself is breathing? I know, it sounds a bit out there, but imagine for a second that space-time isn't just some empty, passive stage where all the events of the cosmos play out. What if, instead, it's actually a rhythmic, vibrating fabric, a fundamental hum that dictates the literal laws of reality, from the tiniest atom all the way up to the largest galaxy?
Welcome to This Explainer. Today, we're unpacking a completely radical reimagining of physics proposed by independent researcher David L. Poole. It's called the vacuum breathing theory, or VBT for short. This framework is wild because it attempts to replace the probabilistic, random nature of standard quantum mechanics with a strictly deterministic model. And it bases this all on one profound idea: a universally synchronized, elastic vacuum.
Okay, let's jump right into the agenda. We're going to cover the breathing vacuum postulate, look at atoms on a Planck carrier, rethink the quantum leap, scale all the way up to gravity and dark matter, and finally, look at exactly how to test this theory. All right, starting off with Section 1, the breathing vacuum postulate, where we view space-time as an oscillator. Modern physics gives us a few different ways to look at the vacuum. Quantum mechanics sees it as a statistical state of probabilities. Relativity treats it as a geometric manifold that bends and curves. But VBT steps in and says, no, the vacuum is a real, physical, elastic continuum, and it's undergoing a globally synchronized breathing motion at the Planck frequency, which is, frankly, unimaginably fast. What this means is there's essentially one universal clock, a globally uniform phase, while the amplitude, like how deeply it breathes, varies from place to place.
So picture these rapid, instantaneous oscillations, the incredibly fast Planck frequency movements. Bounding all of that is a peak-to-peak envelope bounded by the Planck length at its floor. But slicing right through the middle of that is a slowly evolving mean amplitude. Over cosmic time, that average amplitude just drifts smoothly upward. It's actually this slow cycle-averaged background that we experience as the smooth space-time of our everyday lives, which completely hides those hyper-fast oscillations underneath.
Moving right along to Section 2, atoms on a Planck carrier. Let's zoom in and use a radio wave analogy to see how this works. To really wrap our heads around this, think of an FM radio transmission. You've got a high-frequency carrier wave, and the actual music you hear is just a slower modulation riding on top of it. In VBT, the superfast carrier wave is the Planck frequency breathing of the vacuum itself. The slower envelope riding on top, that's the matter wave, like an electron. According to the source, what we perceive as a particle's mass actually just comes from the slight detuning or phase mismatch between that slow matter envelope and the ultra-fast vacuum carrier wave. And when that envelope is mapped out in 3 dimensions, we get a spatial probability density. Why is this absolutely crucial? Well, it directly tackles the famous Heisenberg uncertainty principle. In VBT, uncertainty isn't just some abstract mystical law of nature, it is a hard mechanical geometric constraint. If you try to sharply localize the slow matter envelope, you inherently disrupt its phase alignment with that underlying Planck carrier. You literally cannot perfectly resolve both the amplitude and the phase of a slow modulation riding on a lightning-fast carrier wave. The uncertainty is just built right into the geometry of the vacuum. So the big question is, how does this create stable atoms? Because in classical physics, an orbiting electron should just constantly radiate energy and crash into the nucleus. It was a massive mystery. Niels Bohr just postulated that stationary states don't radiate, but he didn't really explain why. VBT actually gives us a mechanical reason. As the vacuum breathes, the electron's wave loops literally phase lock to that breathing. And because it's perfectly synchronized with the universal carrier, its velocity relative to the vacuum is periodic. The cycle average radiation just cancels out entirely, no escaping energy, which gives us a perfectly stable atom. Which brings us to Section 3, rethinking the quantum leap. How do these atoms actually change energy states deterministically? There's a really stark contrast here between standard quantum electrodynamics, or QED, and VBT. Standard QED basically treats spontaneous emission like a game of dice. An atom decays randomly, makes an instantaneous, probabilistic jump, and emits a photon with an exponential decay that has zero memory of its prior state. VBT argues the exact opposite. It says transitions are completely deterministic. An electron doesn't just instantly teleport between orbits. It gets driven out of its locking range and smoothly migrates to a new resonance. It requires a finite, measurable causal delay to physically resynchronize or relock with the vacuum. When you compare the predictions for emitted light, the difference is night and day.
Standard QED predicts an immediate onset, followed by a memoryless exponential tail, and a constant frequency. But VBT? VBT predicts a clear causal delay, because remember, the electron needs time to relock, followed by a finite Gaussian-like packet. And the frequency doesn't stay constant. It predicts a linear chirp. The frequency actually sweeps as the system physically interpolates between the initial and final orbital frequencies.
All right, zooming way out for section 4, gravity and dark matter, scaling this atomic mechanism up to the cosmos. It's wild, but the exact same equations governing an electron phase locking to the vacuum scale all the way up to explain the entire universe. General relativity and gravity naturally emerge as spatial gradients in the vacuum's breathing amplitude. Massive objects just slightly suppress the breathing amplitude, creating a curve. What about cosmic redshift, which we usually say is galaxies flying away from us? VBT explains it as the slow temporal relaxation of the vacuum field itself over billions of years. And dark matter? VBT eliminates the need for it entirely. It argues that distributed stellar mass black holes locally anchor the elasticity of the vacuum, creating the exact galactic rotation curves we observe. No invisible, non-baryonic particles needed.
But, a theory is only as good as its proofs. So, section 5. How to test the theory using falsifiable predictions. VBT isn't just some abstract philosophy or thought experiment. It offers concrete, testable math. Remember that causal delay we talked about when an electron jumps orbits? Well, VBT predicts a very clear linear scaling for that delay. This is literally the theory's core falsification test. The delay should scale perfectly with the ratio of coupling strength to phase mismatch. By doing controlled sweeps of coupling and detuning rates in a lab, using trapped ions and single photon counting, physicists can directly put this to the test. The source document lays it out pretty plainly. Observing a linear relation here would strongly support VBT, whereas a null result would just reinforce the standard QED model. It is a direct challenge, one that could definitively upend a century of established physics if proven right. To sum it all up, vacuum breathing theory attempts to bridge the microscopic and the macroscopic, from the fundamental reason an electron doesn't crash into a nucleus to the deterministic sweeping chirp of an emitted photon, all the way up to the rotation of the Milky Way galaxy itself. In this framework, there aren't separate rules for the quantum realm and the cosmic realm. It proposes one universe, governed by one single mechanism, synchronization with a globally coherent oscillating medium. It's a totally paradigm-shifting way to look at the fabric of space. If David LaPoule's vacuum breathing theory actually holds true in laboratory tests, it means a vacuum is far from empty. It is the master clock of existence. And that leaves us with a pretty profound question to ponder. If the vacuum fundamentally dictates the timing, the structure, and the mass of our reality, are we and everything around us just complex envelopes riding the rhythm of a cosmic breath?